Welcome back to the workshop for one last video on an example for series. So for this example, we want to determine if each of these series converges or diverges. I'm not concerned with finding the sum if it does converge. Mostly I just want to focus on our ability to determine if something converges or diverges. So for the first example, we're looking at the sum from 1 to infinity of 6 to the n over n plus 1. Now, we should be pretty familiar with how quickly 6 to the n grows versus n plus 1. 6 to the n is an exponential function growing very quickly, and n plus 1 is just a linear function, so growing at a consistent or constant rate. In this case, having a slope of 1, it's growing at a rate of 1, you could say. So with the numerator growing faster than the denominator, we would expect these terms to get large. And we might notice that the limit as n goes to infinity of 6 to the n divided by n plus 1, that is the nth term of this series, is infinity. Okay, so we have a problem there. The limit of the nth term does not go to 0. So by the nth term test, the limit diverges. So again, by the nth term test, the series diverges. For our next one, this one is really quite nice. We can observe that this is equal to the sum from n equals 0 to infinity. Right? So noticing our bounds of summation is very important here. So I have it as 1 to infinity, but I'm going to rewrite it as 0 to infinity. And I'm going to say that this is 7 times 1 over 5 to the nth. Now, of course, this has one extra term where n is equal to 0. So I want to subtract, right? So I have this sum. Now I'm going to subtract the first term because I added one extra term there at the beginning. So 1/5 to the 0 power is 1. 7 times 1 is 7. Now, why did I do that? Well, this thing looks like a geometric series, but officially we actually need it to be a sum from 0 to infinity to say that we know what the sum is. So it is a geometric series, and we may not necessarily need to show this, but it's convenient for us to notice that in order to determine what the sum actually is, we have to have the sum from 0 to infinity. That is important. So since the sum from n equals 0 to infinity of 7 times 1/5 to the nth power is a geometric series, that converges. Why does it converge? Well, because our value for r is 1/5, less than 0. So less than 1. 1/5 is less than 1. Hence, the series converges. Excellent. So our series of interest here for part B, that series converges because it can be written in terms of a series that does converge, because we know it converges as a geometric series. All right, for part C here, we have the sum from 1 to infinity of cosine of n times pi. Well, if you just think of cosine, that doesn't really tell you a whole lot, right? Its value is between 1 and -1, but this isn't really super helpful unless we take a look at what exactly the first several terms of this series are. So for the first term, for n equal to 1, the cosine of pi is -1. All right. For n equal to 2, the cosine of 2 pi is 1. For n equal to 3, the cosine of 3 pi is -1. Cosine of 4 pi is 1. Cosine of 5 pi is -1. And this continues on for forever. So what happens here? Well, if we take a look at the limit as n goes to infinity of the nth term, cosine of n pi, this does not exist. Right? It doesn't converge. This sequence does not converge. So the series diverges. It doesn't diverge to positive infinity, and it doesn't diverge to negative infinity. It diverges because it does not converge, right? It goes from negative 1 to 0. 0 minus 1 is negative 1. Negative 1 plus 1 is 0. So the sum is actually going back and forth between negative 1 and 0. So because the sum does that, we have that the series diverges. Excellent. And for our last example, we want to take a look at the sum from 0 to infinity of 5 times n factorial divided by n plus 1 factorial. First thing to notice is that this is the sum from n equals 0 to infinity of 5 times n factorial divided by n plus 1 times n factorial, allowing us to cancel out the common factor of n factorial in each case. So this is just the sum from 0 to infinity of 5 over n plus 1. Well, we're not really sure. This isn't a geometric series, and it doesn't appear to be a telescoping series. So what does it do? Well, we can say that the limit as n goes to infinity of the nth term, 5 divided by n plus 1, is equal to 0. Hey, excellent, cool. That means it converges, right? No. The nth term test only tells us when a series diverges. So if it's equal to 0, that doesn't tell us anything. This just tells us that it could converge. We do not know that it does. So, we don't know what happens with this series. It's going to take a little bit more knowledge, a little bit more testing for us to be able to determine if this series converges or diverges. Later, we'll find that this diverges. But what we want to focus on right now, or for the last bit of this video, is our tests for convergence and divergence. Because clearly, we don't have the ability to determine in every situation what happens. So our ability to test amounts at this time to determining if it's a geometric series. If it is a geometric series, then we are able to determine if it converges or diverges. If it's a geometric series where the r value is less than 1, then it converges. If the r value is greater than or equal to 1, then it would diverge. So that is one of our tests right now. And then we have the nth term test. But this is only for divergence. Right? The nth term can only tell us if the series diverges. So if it's not a geometric series and the nth term does go to 0, then we don't really have the ability to determine what happens. There are maybe a few special cases of if it happens to be a telescoping series. If you're able to observe that, then you would know that it converges as well, or you suspect that it will. Right? You might have a telescoping series that for some reason also diverges. At least that scenario would not surprise me. So you do need to be careful. You might be able to find if it converges or diverges using a telescoping series. If it is, a telescoping series that is. But otherwise it's geometric series and nth term test. For more methods, we'll continue on into the next section. Otherwise, that's all that I have for series. I'll see you guys shortly.